part of our lesson deals with molecular formulas. A molecular formula tells the exact number of each type of atom in a compound. For some formulas, this is going to be the same as the empirical formula, or it's going to be a whole number multiple of that empirical formula. Let's take a look at a couple of examples. So here I've given you the molecular formula, and we're going to figure out what the empirical formula is from that. Remember, the empirical formula is the lowest whole number ratio of the atoms. So if we look at the first one, H2O, we see that we have a 2 to 1 ratio. Since that can no longer be simplified, our empirical formula would just be the same, H2O. Now in the second one, we see that we have some atoms kind of split out. That is to show structure. So let's go ahead and combine them together to make it a little bit easier. So we have 2 carbons, 4 hydrogens, and 2 oxygens. So we see that we end up with a 2 to 4 to 2 ratio. If we divide all of those by 2, that can reduce it down to 1 to 2 to 1. So my empirical formula would be CH2O1. The second one, or the next one, we see has a 1 to 2 to 1 ratio. Again, that's as simple as it can go. So its empirical formula is again the same as the molecular. And finally, the last one has a 6 to 12 to 6 ratio. We can simplify that one by dividing all of them by 6. And again, we get CH2O as our empirical formula. So if we look at these last three, we see that they all have the same empirical formula. However, these are 3 very, very different compounds. This first one is vinegar. The next one, formaldehyde, which is used in a lot of preserving dead bodies and that kind of thing. And the last one is glucose. So as we see, 3 very different compounds have the same empirical formula. So empirical formula is probably not the most useful. Molecular formula is going to be the most useful for us. So let's take a look at how to determine that molecular formula. So I have an example. It says a 1.50 gram sample of hydrocarbon undergoes complete combustion to produce CO2 and H2O. The empirical formula of this compound is CH3. Its molecular weight has been determined to be about 60. What is the molecular formula? Now, anytime you're trying to find the molecular formula, you must have 2 things. The first one is you must have the empirical formula. You must also have the molecular weight, or is sometimes called the molar mass. Okay, so in the case of this example, we see that we are given the empirical formula, which is CH3. We are also given the molecular weight, which is 60. Since we have those 2 pieces of information, we are able to find the molecular formula. The first thing we need to do is find the molecular mass or the molecular weight of our empirical formula. So just like we've been doing, we'll split it apart. Have 1 carbon. Carbon has a mass of 12. 3 hydrogens, each with a mass of 1. So my total mass is 15. Since the mass of my empirical formula is not the same as the molecular weight of the compound, we know that they are not the same. So our job now is to figure out how many times larger is that molecular weight than this empirical formula. So to do that, we're just going to divide. So I'll take the molecular weight of the compound divided by the molecular weight of the empirical formula, which tells me that the actual compound is 4 times larger than that empirical formula. So I'll then take that 4 and multiply it by each of our subscripts. So my final molecular formula is C4H12. Okay, at this point, pause the video and practice this next example. You should have gotten the answer C8 H10, O2, N4. Let's see how it's done. So example 4 says, caffeine has the following percent composition: carbon 49.48%, hydrogen 5.19%, oxygen 16.48%, and nitrogen 28.85%. Its molecular weight is 194.19 grams per mole. What is its molecular formula? Okay, so again, they're asking us to find the molecular formula, so we have to have two things. The first thing we have to have is the empirical formula. Well, in this case, they did not just tell us the empirical formula, but they did give us a percent composition, so we can use the poem from the last video to find that. The second thing we need is that molecular weight. They did tell us that is 194.19. So let's start off by finding the empirical formula of this compound. If you remember from the last video, we had a poem with the 4 steps to find that. Percent to mass, mass to mole, divide by small, multiply to whole. Okay, so first off, we need to change our percent to mass, so we just change the percent signs to grams. So 49.48 grams of carbon, 5.19 grams of hydrogen, 16.48 grams of oxygen, and 28.85 grams of nitrogen. Step 2 is to change our mass to mole. So we're going to divide each of these by their molar mass. Carbon is 12. Hydrogen is 1. Oxygen is 16. And nitrogen is 14. Okay, so we'll do the math. 49.48 divided by 12 gives me 4.12 moles of carbon. I did 5.19 divided by 1, which is just 5.19. 16.48 divided by 16 is 1.03 moles of oxygen. And 28.85 divided by 14 is 2.06 moles of nitrogen. Okay, the next step is to divide by small. So we look at our 4 numbers. We see that 1.03 is the smallest. So I'm going to divide all of my numbers by 1.03. Obviously, that gives us a 1 for the oxygen. 4.12 divided by 1.03 gives us a 4 for the carbon. 5.19 divided by 1.03 is 5.0, which we can round to 5. And 2.06 divided by 1.03 is 2. So in this case, we see that we have all whole numbers, so we do not need to find a multiplier. Therefore, my empirical formula for this compound is C4H5ON2. So now we have the 2 pieces of information that we need to find our molecular formula. As we did before, the first thing we need to do is find the mass of the empirical formula and check to see if it's the same as the molecular weight. So my empirical formula is C4H5ON2. So let's find the mass of that. We split it up into its 4 elements. I have 4 carbons. Those are 12 each, which is 48. I have 5 hydrogens, 1 for each of those, so 5. 1 oxygen, 16. And 2 nitrogens at 14 each is 28. So the total mass of my empirical formula is 97. So we see that the empirical formula's mass and the molecular weight are not the same, which means that our empirical formula is not the same as the molecular formula. So we need to find how many times larger this molecular weight is than this empirical formula. And to do that, we'll just divide. So I'll take the molecular weight, 194.19, divided by the empirical formula's mass of 97, which comes out to be 2. So that tells me that the actual compound, the actual molecular formula, is 2 times that of the empirical formula. So my final molecular formula will be C8H10O2N4. For the rest of class and your homework tonight, you need to complete the percent composition and empirical and molecular formula problem set in your packet. You also need to complete the plane crash assignment in your packet. Once you have identified all of your victims, don't forget to write up your final report. That is down at the bottom of the worksheet.